Hello, my AB kids. I'm missing you. I hope you're all doing well. We're starting section 10.2 on something called U substitution. We're still talking about how to integrate and how to find integrals. Section 10.2 has the U substitution when you don't have bounds, the indefinite integral. And section 10.3 is going to be when you do have bounds. So in this section, without bounds, you'll need to remember to add your plus c at the end. And in section 10.3, you'll need to then evaluate it doing the f of b minus f of a, things that we've talked about before. So just an overview on all of that. So what is this U substitution and what is it good for? When do you need to use it? And the deal is, if you see something complicated like this that you want to find the integral of, and you're trying to undo a chain rule, that's when U substitution comes into play. So when is U substitution necessary? It's necessary to integrate an example of a chain rule. To integrate a chain rule, which is what these are. Now I'm going to show you two different ways to do it. Let me show you the old school way, and then I'll show you the new school way. So, old school way. We can turn this into a polynomial by taking x squared plus 1 and squaring it. Turning this into a polynomial is what we're working on. So x squared times x squared is x to the fourth. X squared times 1 is x squared. Plus another x squared gives me 2 of them, plus 1. But that's not really what I have because I still have a 2x in the front of this whole thing. So I need to distribute a 2x through my foliage. All right, so that's going to give me 2x times x to the fourth, or 2x to the fifth. It's going to be 2x times 2x squared. That gives me a 4x cubed. And 2x times 1 is 2x. All right, now I've got a lovely polynomial that I can then integrate. So remember the rule. You're going to add a power on and divide by the power. So that gives me 2x to the sixth over 6, 4x to the fourth over 4, and 2x to the second over 2. And then I have a plus c because I do not have bounds. And so trying to clean this up, that would be 2 6 is 1/3. X to the sixth, the 4's cancel, x to the fourth, the 2's cancel, x squared, plus c, and there's your integral. Now that would be the old way of doing it with polynomials. So here's the new way of doing it. You have to figure out, you're going to substitute in a value called u. And the u value is either normally what's in parentheses or what's under a square root, or whatever the ugliest part of this function is. So if I think about that, whatever's inside the parentheses in this case would be x squared plus 1. So I'm going to call that u. I know that's a weird kind of letter, but that's what they use. Why it's called U substitution, right? So u equals x squared plus 1. And then what you're going to do with that is you're going to find the derivative of that. So du is what you're going to find. Technically it's du over dx. I'm finding the derivative of u. So if I do that with respect to x here, I've got a 2x. The derivative of 1 is 0. And so this is what my du would look like. Now we're going to write that. Multiply both sides by dx. Gives you 2x dx. And normally I just go right to this step. If u is x squared plus 1, du is 2x dx. All right, here's where substitution comes into play. You can see here that this value here is your u. So I'm going to reset up this integral based off of what I just said here. My u, x squared plus 1, is being squared. I have a u that's being squared. I have an x squared plus 1 that's being squared. I called it u. The second piece I have is that this 2x and this dx, 2x dx, are called du. And so I can substitute that in. And so now I've got a u squared, the integral of u squared, times du. If I take the integral of that, I raise the u to one more power, I divide by that power. and then I put a plus c at the end. But the story is, with these, you're going to then go back to what u actually is. So this would be like, I'm going to put it down here, u is x squared plus 1 cubed over 3 plus c. All I did was replace it back. I called u x squared plus 1. Now I'm calling it x squared plus 1 again down in here, replacing that u. So I wonder are these equivalent forms? I'm like, I don't know. Are they equivalent forms or not? So I'm going to go to my handy dandy calculator, and I'm going to look at the expand function. And I did this a little bit earlier just to save some time. So in the expand function, I put in, all right, well, what is x squared plus 1 cubed with respect to x? And the calculator popped out this. It said, all right, well, that equals, let me put it here, x to the 6th plus 3x to the 4th plus 3x squared plus 1. That's what, if I were to cube this out, it would look like. And again, I just did that. It was in the algebra menu. See the expand number 3. So I just plugged it in there, and that's where I got. So that's my numerator. Here's my denominator. Plus c. So I'm going to divide these out. That gives me a 1/3 x to the 6th. The 3's cancel. I get a plus x to the 4th. The 3's cancel. I get plus an x squared. And then I get, well, I really probably don't need this c because it really is my constant value. This at the end is my c, my constant value. Oop, I went off your page. Let me show you what I'm talking about. Oop, there you go. All right, so these are actually equivalent to one another. So this u substitution is a whole different ballywick, and it comes into play whenever you're trying to undo a chain rule, trying to integrate a chain rule. I'm going to show you a few more examples. So in this box, each rule for derivatives yields a corresponding rule for integrals. We know that integrals and derivatives are related to one another. We had been studying that right before we went on break. So the derivative of a capital F of x function ends up being the actual function itself, right? If I take the derivative of the antiderivative, I end up back at the middle. So they're going to just kind of show you that really quick here. The derivative of sine x cubed, derivative of sine is cosine. I keep the same angle. But then I have to take the derivative of what's inside, what the angle is, times 3x squared. Well, that tells me that if I take the integral of the cosine of x cubed times 3x squared with respect to x, what is that going to give me? It's going to take me back to the original function. So that's going to equal the sine of x cubed plus c. So we've determined that the antiderivative of the cosine of x cubed times 3x squared. This is just another example telling you how if you take the integral of a function, it ends up equaling the derivative, if you take the derivative of a function, it ends up equaling the integral of that, whatever that is. So you can kind of go back and forth with these. This is that fundamental theorem of calculus that we've talked about before. All right, so let's take a look. Here are the suggested steps by u substitution. You're going to have some type of a composite function. You're going to have a function and then another function within it, a chain rule type thing, more than one function inside. It's called u substitution. So the first thing that you want to do is you want to figure out what your u is. And so I told you in that last example, u is what's inside of parentheses or inside a square root or something like that. Or sometimes it's just the most ugly thing you got going on. Most ugly function in what you're given. So you need to figure out u. That's the first thing. Find u. Second thing is find du. Find the derivative of whatever that is you chose. Then you're going to substitute the values of u and du into your integral, and then you're going to be able to compute the integral and then replace it back with the x function that you started out with. All right, so 4 steps. Let's see if we could try a couple. So if I'm looking at this one, this next one, The most ugly piece is this cosine of x cubed piece. And what you're going to do is you're going to let what's inside the parentheses be your u. So let's see, if I do that, u equals x cubed, du equals 3x squared dx. All right, let's see if we can substitute it in, because if you can't substitute them and they don't line up quite right, then you're going to end up not having to be able to use this method. You've got to find a different method. So I'm looking at this. I see I have an x cubed dx. I have this. That's awesome, but it doesn't have a 3 with it. But I can fix that, because what I can do is divide by 3 over here. That's going to give me du over 3, or 1/3 du. Well, 1/3 du equals x squared dx. All I did was divide by 3, which is going to let me set this up, because that piece here is going to equal 1/3 du. Let me see if I can fit my substitutions in here. Here's my integral. I have a cosine. I have x cubed, which is u, and I have x squared dx is equal to a 1/3 du. So I'm putting that substitution in there. Well, constants can come out in front of the integral, so really this is like 1/3 the integral of the cosine of u du. And if I take the integral of cosine, well, the integral of cosine is sine, so that means that this is equal to 1/3 the sine of u. U, the derivative of that is just 1, so that's okay. And then I've got a plus c. And then the last step, so I computed the integral with my u. Now I'm going to replace the u with what I actually told you it was in the beginning, and that means that my final best answer is 1/3 the sine of x cubed plus c. And that is a u substitution example. We're going to do a few more because these are really weird. All right, here comes the next one. I've got x times the square root of 1 minus x squared. What's inside the root? What's inside the parentheses? What's the ugliest part of this whole thing? That's your u. So u equals, in this case, 1 minus x squared. So identify the u, and then you're going to figure out the derivative of it. Well, the derivative of 1 is 0. Derivative of negative x squared is a negative 2x dx. And I look back at what my integral really is, and I have an x, I have a dx, but I don't have a 2, or a negative for that matter. So I'm going to divide that through. If I divide by a negative 2, that makes this be a negative 1/2 du equals x dx. And so I'm ready to do my new integral in bases of u, or in letters of u. So I have the x dx. They are this. They're the negative 1/2 du. What I really have is the square root. So I've got u to the 1/2, the square root of u, times x dx, which is a negative 1/2 du. So in my replacement, in my substitution, I've got the square root of u, and I've got, this would be equivalent to what my negative 1/2 du would be. So let's make it pretty. So take the negative 1/2 out in front. I have the integral of u to the 1/2 du. Negative 1/2 stays in front. I want the integral of a u to the 1/2. So I need to raise it to a power. That means it's now to the 3/2 power. And I need to divide by that power. So if I divide by 3/2, I'm really multiplying by 2/3. Remember, we've seen that before. U to the 3/2. And then I'll have a plus c with that. All right, so let's see what we got. Clean it up. 2's cancel. I have a negative 1/3 u to the 3/2 plus c. But I know what u is. Probably bad English, right? I know what that u is 1 minus x squared. So I get a negative 1/3. I have a 1 minus x squared. It's being raised to the 3/2 power, and then I have a plus c. And that is my final answer for that example. We got 3 to go. All right, so the next one, this one's a little bit trickier to figure out what the u is. And it's all based on what your integrals would be and what your derivatives are. So if I look at the next one, if I think about letting u, the ugliest part of this is really the secant squared, or what I would probably choose to be. But if I take the derivative of a secant squared, I get this whole secant tangent thing, which would be really ugly and it's squared and all that stuff. But think about if I take tangent and take the derivative of that, the derivative of tangent is secant squared. Well, that's going to line up pretty nice in my substitution. So this time I'm going to let my u equal the tangent of 3x. Keep it in parentheses. That means that du equals, the derivative of tangent is secant squared of 3x, and then times the derivative of what's inside times a 3 dx. I can see in my problem I have a secant squared 3x. I don't have a 3. So that means that I'm going to divide by that 3. That means this is going to be a 1/3 du equals a secant squared of 3x dx. And then I'm going to see if I can make my substitution. So here comes my new integral. New integral is, I have a secant of 3x dx. That takes care of this. Secant squared of 3x dx is equal to a 1/3 du. And then I still have a tangent of 3x, that's my u, but it's in the denominator, so a 1/u. Let me see if I can clean that up a little bit. I got the integral of 1/3 times 1/u du. Well, the 1/3 comes in front. 1/u du. And then I'm looking at what's the integral of that. Well, 1/u, that's the weird one, because that would be like u to the -1, and when I add 1 on, I get a power of 0, and you're like, wait, there's got to be a different way, and it's ln's, if you remember correctly. So this would be 1/3 times the ln of u plus c. We know what u is, what u be. I get 1/3, the ln, u is the tangent of 3x. Now, ln's always have to be the absolute, they always have to be positive, so you're going to put the absolute, technically they put the absolute value there to show that you really know that it's going to be a positive value. You can't take the natural log of a negative, and so your answer is 1/3 ln of tangent of 3x plus c. That's your final answer. 2 to go. The last one's really simple. All right, here's the next one. What's the ugliest part? Oh, I'm looking. What's in parentheses? Here it is. U is x to the 4th plus 2. What's du? 4x cubed. Ooh, plus 0. Dx. All right, I have an x cubed. I have a dx. I don't have a 4. 4's going to the other side. 1/4 du. Let's see if we can integrate and set this up. So I will have a 1/4 du. If you want to do that part first, that's fine. And I have a cosine of u. 1/4 comes in front. Cosine of u du. Well, what is the integral of a cosine? And you say, well, that's sine. So I have 1/4 the sine of u plus c. What's u? I'm going to replace it. U is x to the 4th plus 2 plus c, and that's your final answer for that guy. All right, finishing it out. Last little bit. Got to have an e in there, right? A little bit of an e. So this one, inside the radical, ugliest part is a u of 1 plus e to the x. If I du it, if I take the derivative, 0. Derivative of e to the x is e to the x. I do not have to make any kind of changes like I did up here where I had to divide by 4, because I have an e to the x and I have a dx. There you go, it's du. Set up the new integral. New integral is, I'm taking my u value and taking the square root of it to the 1/2 power, and then my du is the e to the x dx. All right, finding the integral. If I've got, raise it to 1 more power, That's going to be u to the 3/2 power, and I'm going to be dividing it by 3/2 or multiplying it by 2/3. So put it all together, 2/3. My u is 1 plus e to the x. My power is 3/2. I got a plus c. And there you go, my friends. That is an introduction into u substitution. I can tell you when you watch the video from the Flip Math folks, it's going to run really fast, and you might have to pause it every once in a while and be like digesting it as you go. So this was our intro lesson, kind of giving you the flavor of it. And if you have questions or any concerns, just email me, and I'll talk to you soon. Miss you. Bye.